James Webb discovers huge distant galaxies that theoretically shouldn't exist. Welcome to our channel where we will keep you updated on the latest discoveries and advances in the world of astronomy, science, and technology. We are here to bring you the latest and most important news from the scientific world. Join us to explore the latest news across all areas of astronomy and find out how it impacts our everyday lives. If you are an astronomy enthusiast like us, this channel is for you. Don't forget to like and share the video and subscribe to our channel so you don't miss any news. The James Webb discovers giant, mature galaxies that appear to have filled the universe shortly after the Big Bang, and astronomers are baffled why they shouldn't be there. And now no one can explain how they formed. Galaxies nearly as massive as the Milky Way and filled with mature red stars appear to be scattered in deep field images taken by the James Webb Space Telescope during its initial observing campaign, and are giving astronomers a headache. These galaxies, described in a new study based on Webb's first data release, are so far away that they appear only as tiny reddish dots to the powerful telescope. By analyzing the light emitted by these galaxies, astronomers established that they were observing them in the infancy of our universe, just 500 to 700 million years after the Big Bang. These first galaxies are not surprising in themselves. Astronomers expected the first star clusters to appear shortly after the universe emerged from the so-called Dark Ages, the first 400 million years of its existence, when only a thick fog of hydrogen atoms permeated space. But the galaxies found in the James Webb images looked incredibly large and the stars in them very old. The new findings are at odds with existing ideas of how the universe looked and evolved in its early years and do not match previous observations made by Webb's less powerful predecessor, the Hubble Space Telescope. We had specific expectations for the type of galaxies living in the early universe. They are young and small, said Joel Leha, an assistant professor of astronomy and astrophysics at Penn State and one of the study's authors. Previous studies of the early universe with Hubble and other instruments tend to find small, blue galaxies in early times. Objects that formed recently from the primordial cosmic soup and are building their first stars and structures. Young stars generally glow bright blue. With age, stars develop a redder glow as they burn through their fuel and cool. In ancient galaxies that Webb was built to detect, astronomers didn't expect to see old red stars. They also didn't expect to find galaxies more massive than perhaps a billion suns. But these reddish spots revealed in Webb's deep fields look 50 times more massive than that, Leha said. The most massive galaxies in our sample were estimated to have masses 2 to 4 times smaller than our own Milky Way. We are finding candidate galaxies as massive as our own galaxy when the universe was 3% of its current age. Leha said that before astronomers start rewriting cosmological theories to explain how these galaxies came together so quickly after the Big Bang, they'll have to make sure the weird red dots they're looking at aren't something else. Most alternative explanations, however, also require entirely new concepts. For example, stars in the early universe can emit light in exotic ways due to a lack of heavy elements, and perhaps we are not incorporating these into our models or, alternatively, perhaps our understanding of how stars form locally, for example, how many stars form from gas as a function of the mass of the stars is totally inapplicable in the early universe. These things would also be exciting to find out and would also overturn our understanding of star formation in the early universe, just in a very different way. The images that revealed these intriguing galaxies were taken by Webb's near-infrared camera, NIRCam, as part of the Cosmic Evolution Early Release Science program. Astronomers soon plan to turn the Webb mirror on these galaxies again, this time to obtain spectra of light from these distant points. Spectra break down observed light according to its wavelength composition and thus reveal the chemical and physical properties of its source. The most important thing is that the spectra provide very accurate distances to these objects, said Leha. The distance and identity of these objects are correlated. If we know the distance, we can define the identity, and vice versa. So a spectrum will tell us immediately whether our hypotheses are correct. Just over 6 months after the Webb team released the first observations from the Large Observatory, scientists are already challenged to rewrite their theories about the early universe. We looked at the early universe for the first time and we had no idea what we were going to find. It turns out we found something so unexpected that it actually creates problems for science. This calls into question the whole picture of early galaxy formation. So, did you like this video? So be sure to like and share with your friends. This helps us bring you more exciting news from the scientific world and expand our community of science and astronomy enthusiasts. Don't forget to subscribe to the channel and turn on notifications so you don't miss any news. Thanks for watching, and until the next video.